Okay, so I guess we're at time. So good afternoon. Welcome to the Lake meeting. It's Ietf114. My co-chair Militia is remote, but is popping on screen to say hello.
Hello, this is Militia speaking.
Great. I think Marco has kindly agreed to take notes, so thank you, Marco. We'll keep an eye on the chat ourselves as chairs. Okay, so there's the note well. I guess you've seen this before during the week. Have a quick read and enjoy it. Additionally, as a hybrid meeting, we need to kind of pay attention to remote people. So if you're remote, please keep your audio and video muted unless you need to speak. If you're here and you want to go to the mic, please join the queue if you can. But we don't have thousands of people, so it's probably quite manageable. But no harm to join the queue if you can do so before going to the microphone. And if you go to the microphone, please also state your name. You need to click onto the data tracker somewhere or scan the QR code as Paul is doing in order to sign into the meetings for record keeping. So please do that too. So there's some links in case you need to do a bit of clicking. And here's our agenda for today. So administrivia we're doing. Then we'll have Mark will talk about some computational analysis, as then will Baptiste. So the main kind of goal of today's meeting is to get this feedback from people who've been doing analysis of the protocol. Then John, I think, will give us an update on the draft and traces and so on. And Marco has a quick report on the hackathon. And then we have one other thing, Militia, sorry, I forget what it is. Can you remind me?
Yes, so we received one request from Marek to give an update on his work on test vectors, but I don't see Marek in the participants list. So with that, I guess if we can just do the regular agenda bashing, see if anyone else has any proposals.
So great. So if he shows up and we have time, we'll get to that.
Yes.
And then finally, we want to try and discuss what else we think is needed before we get to working group last call and move towards being done. So status, Militia, I think you wanted to talk to this?
Yes, so I wanted just to give a brief update on the status. So essentially, as Stephen noted, we are kind of wrapping up the formal analysis stage of the protocol. During the previous Ietf114 meeting, we had the symbolic analysis presented of all Adhoc authentication methods. In this meeting, we will have two presentations on computational analysis of method 0 and method 3 by Mark and Baptiste respectively. So as you can see, we have kind of almost all parts of the protocol covered, which is great. On the implementation security side, I won't be giving an update as due to the lack of agenda time, but we made some good progress on that and completed the HackSpec implementation that I mentioned during the previous IETF meeting. I will be giving an update on the implementation security of one particular implementation during the London meeting during the Ietf114. So as Stephen noted, the goal of this meeting is kind of to gather the final results from the formal analysis stage, as well as to discuss what else is needed before the working group last call. So one note, we created a page, Lake workinggroup.org, lakewg.org, where we are keeping track of the different activities around the working group, mainly interoperability testing, formal analysis, some informal presentations of the protocol, like key schedule. So just something that facilitated the formal analysis in the past. So give this a look, and we welcome any feedback if you have any on this particular page. That would be pretty much it on this slide. One more aspect that I forgot to mention previously: the external people people external to the working group have mostly been referring to the protocol as a lake. So we, as chairs, we wanted to kind of brief, kind of poll the working group on the question whether renaming Adhoc to Lake makes sense, and we will be doing this in the next days on the mailing list. So that would be all I wanted to mention on this slide. I think we can go ahead with our first presenter, unless Stephen, you have something to add.
Yeah, I neglected to give people an opportunity to actually bash the agenda. So does anybody want to bash the agenda? Not seeing anyone? And yes, we'll move to the next presentation.
Yeah, so the first presentation is Mark.
Hello, just testing. You can hear me okay and see me okay.
We can hear you and see you, and you should have control of the slides.
Perfect, thanks. Then I guess I can get started. Right, so hello everyone. So in this short presentation is about our work on a computational analysis of Adhoc 6.6. The work was done in the context of my master thesis, which is being supervised by Felix Gunther at ETH Zurich. Given the time restriction, I will only focus on the most interesting insights of our analysis. Edited write-up should be available once the thesis is completed in a few weeks' time, actually in a week. With that said, I would like to start by summarizing our main results. The main takeaway message from our analysis is that the Adhoc 6.6 is structurally sound and secure. We targeted key secrecy, we analyzed explicit authentication and the 4 secrecy guarantees of Adhoc 6.6. For our security model, we analyzed Adhoc in the multi-stage key exchange model that I will briefly explain later. So the main output of our analysis is a security proof for Adhoc 6.6. However, a caveat of our analysis that I should state is that our bound is non-tight. However, we believe that the recent work of Davis et al. On Ietf114 should be a good opportunity there to provide a better, tighter security analysis of Adhoc 6.6. Along the way, in this analysis, we also gained some insight into the marked and signed protocol that we'll share as well in hope that it helps with potential further development. So let me then start by explaining our security model. As mentioned, we analyzed Adhoc in the multi-stage key exchange model. We closely followed the work of Doling et al. On analyzing the TLS 1.3 handshake protocols. So in the MSK model, we consider a key exchange protocol here denoted by pi that can be used, for example, to establish a key to communicate over an insecure channel. Furthermore, users will run typically multiple concurrent instances of the protocol that we call sessions. We additionally consider a strong adversary that can compromise long-term secrets, can eavesdrop and modify messages arbitrarily so they have full control over the network. Key indistinguishability then will capture the notion of the secrecy of the session key. Seems there is a question. So the goal of the adversary is, given access to either a freshly generated session key or a random one, they should try and distinguish which they received. A closer look at Adhoc shows that Adhoc is not just a protocol that derives a single session key, but there are actually multiple stage keys that are derived throughout the protocol, in particular 4 in our model. So the MSKE model is adapted to Adhoc. So in particular, multi-stage protocols may introduce dependencies between stage keys that are potentially unwanted. And so the MSKE model allows us to capture such issues, and it also enables fine-grained analysis of the stage keys, thereby giving an overall security proof. Explicit authentication was of particular interest in our analysis, and this will be the subject of the remainder of my talk. Very informally, explicit authentication captures the fact that for authenticated stages, only the peers knows about the stage keys, and they also demonstrated actively knowledge of that key. However, in Adhoc, we particularly looked at the specification for credential identifiers and the possibility that they may be non-unique. There is sort of an ongoing discussion going about this. And what we did is that we took a very conservative approach and we modeled this aspect by assuming that all all credential identifier may be non-unique. And furthermore, in our model, we actually allowed the adversary to choose these identifiers arbitrarily in order to essentially see what sort of security guarantees we can have in Adhoc. So with non-unique identity credentials identifier, so at glance, it seems like a receiver of a message, for example, here the initiator, would have to verify multiple public keys related to the same identifier in order to then validate the identity of the peer. So in the scenario that I'm depicting here, we see that we could have an adversary who would intercept the second message. And then what they would do in our model is that they can then register a new user with a public key that is associated to the same ID cred. And this key pair is specially generated in a way that for every message and signature, this public key always verifies. And the consequence of this is that this protocol, as depicted here, at least this sort of simplified version of Adhoc, will run through, and the protocol will not stop. And I will explain a bit later why. So here we're saying that, again, I've sort of simplified Adhoc by showing that in the second message, the receiver, the responder would send sort of a key identifier, a signature, and then some message. Obviously, the message is not really sent in Adhoc, as we know, only sort of partially. And interesting observation is as well that the message that the actual responder sends is always different than the one that will be verified for the malicious key. This is because the credentials are signed. If you recall the run of Adhoc, the credentials are signed, therefore the messages are always different. So the natural question then here was, what type of security guarantees do we need from the signatures? Well, we realized that in fact we need more than the normal unforgeability that is usually sort of the minimal required guarantees. In the previous attack, actually, the transcript hashes, as you've seen, the adversary never changes the communication transcript. So the transcript hashes nor the keys are modified. Therefore, the protocol runs through without error. So this inside the fact that we need, besides unforgeability, we need a notion of exclusive ownership of signatures. And in particular, because, as we said, the messages are different for different users who are authenticated themselves, we need the minimal required security guarantee would be destructive exclusive ownership. Interestingly, the Magden sign protocol would also be vulnerable to a similar attack if the signature scheme would contain weak keys. And additionally, we also saw that the ambiguous nature of CBOR and when it's encoded also prevented some issues that would, for example, come from concatenating byte strings as is done in the computation of the MAC2, for instance. So fortunately, we could show that the signature scheme in Adhoc 6sig provide the required exclusive ownership guarantees. So in particular, Edwards 25519 is known to provide universal exclusive ownership. For ACDSA, it's not really the case. However, the fact that the public key is also signed is enough to provide the security guarantees that we need, namely exclusive ownership. However, this requires that there are no weak keys, and also inside the fact that the implementation must perform all the checks. As we've seen, it's not always the case with the recent CV, for example, on psychic signatures. And beside exclusive ownership, our proof, we also required strong unforgeability instead of just the existential unforgeability of signatures. This is because, in contrast to TLS123, the MAC then sign, the MAC is under the signature, and it's not the other way around, where the MAC also covers the signatures. Without that, the consequence is that an initiator, for example, would accept a second message, even if it was modified by SUF-CMA attack. The consequences here are probably not interesting. It's not clear what practical issue will happen here, but it's good to be aware of this. And as for the signature schemes, well, for Adhoc 2019, while it is known to provide, it is known to be SUF-CMA secure. Obviously, it has to be the Ietf1, as it's been shown that the original Adhoc 25519 is actually not SUF-CMA secure. And for ECDSA, again, there are ways to modify the signatures in a way that breaks SUF-CMA. So to this effect, we suggested two modifications to strengthen explicit authentication, although we could already prove it. Namely, this is to add the credentials to the transcript hashes, as shown there. The benefit is that an attempt to identity misbinding attack, as I've shown before, will lead to diverging transcript hashes, which then sort of stops the protocol and leads to a termination. Of course, assuming with some collision resistance assumption on the hash function. So with all that being said, our main theorem is essentially an upper bound on the advantage of an MSKE adversary, so the MSK being the security model. Again, I can't really go into the details now, but essentially what it shows is that we can reduce the security of Adhoc 6.6 to its main components, namely collision resistance hash function, a strongly unforgeable signature scheme that also provides exclusive ownership, a PRF function, which is the expand on the PRF assumption on the expand function, and the PRF ODH assumption on the extract function. Finally, let me briefly evaluate some of the past suggestions that we proposed to sort of improve the protocol. The first one is having an explicit session key. This obviously made really it easy to prove security and to have sort of a clean indistinguishability proof. And sort of, so by that I mean secrecy proof for the PRK out, which is now the sort of final session key. And computed in transcript hashes over the plain text was our second suggestion. And that also simplified our proof in the sense that we did not rely on some potentially non-standard assumption on the encryption schemes. So with that, I conclude my talk. Thank you very much for your attention, and I'm really happy to take any questions.
Great, and thanks for all the work. I think we have John on the line.
Yeah, John here. Thanks for all this work. You're really great. Just pointing out, the previous recommendations have been included in the latest version. For the update of TH3 and TH4, there is already an PR. There's also ongoing discussion between different teams here in the issue right now, but this seems like it's a very simple change. But please look into the issue and the PR and comment there.
Thank you.
Thank you.
Okay, I don't see anyone else in the queue. So thanks, Mark, again for the work. It's really valuable. And keep doing more of it. Okay, so with that, we'll switch presenter. And Baptiste, if you could jump on. You should have control of the slides now.
Hi, everybody.
Great, thank you. Go ahead.
So, I can go. Do you hear me?
Yes, we hear you, Baptiste. You can go. The floor is yours.
Okay, thanks. So I will present you results of the computational analysis of the Adhoc protocol in the stat
So,
method.
sorry, Baptiste, the audio is a little bit low. I don't know if you could be closer to the microphone or.
Oh, sorry. Is it better now? Oh, no.
So yeah, keep speaking and we'll let you know when it works.
Okay. It's better now, right? Okay. So, present you our result on the computational analysis of the Adhoc protocol in the stat method. So first, we present some hypotheses. We made some notations. So pi, a single pi will be the one-time encryption scheme, while the pi prime will be an authenticated encryption scheme. The A will denote an adversary, and G is a secret group of order P. We choose to denote SKI, the key denoted KI in the specification, and XS is the initiator long-term key that denoted I in the specification. So the first hypothesis we use is the computational Diffie-Hellman. So given G to the U and G to the V, an adversary has to compute G to the EV, and the advantage of the adversary is denoted as you can see on the slide. We also use the gap Diffie-Hellman assumption, so that is the CDH assumption with an access to Diffie-Hellman oracle. So that is an oracle that can answer if a triple is a Diffie-Hellman triple. And the best attack known on this assumption is the baby step, giant step attack that run in a square root of P, where P is the size of the group G. The hypothesis for the symmetry encryption. So we have the injectivity. So for any key in the space of keys, two encryption of different messages with the same keys will result if you have an equality in two encryption of two messages with the same key, it means the messages are equals. Also, you have the one-time undiscussability. So for an adversary, given an encryption of M0 and an encryption of M1, it can say with a consequent advantage which one is an encryption of M0 and which one is an encryption of M1. Now, the hypothesis about the authenticated encryption. So for the undistinguishability, we do the same as previous with an access to an encryption and decryption oracle. So here again, the adversary has to distinguish between an encryption of M0 and an encryption of M1, but he can ask the oracle, can you encrypt and decrypt these messages? So, and the advantage is denoted as advantage in the indistinguishability of p pi in polynomial time t. We also have the unfungibility of the authenticated encryption. So here again, the adversary has an access to the encryption and decryption oracles. You have to generate a valid ciphertext, and the advantage is denoted as the capacity for the adversary to forge a valid ciphertext with chosen messages. So her results. So we use Q arrow to denote the number of queries to the random records, and sigma to denote the number of running sessions, capital N the number of users, L hash is the length of the hash digest, and Lmac is the MAC digest length. So for the key privacy, we have this disadvantage. So that leads to around 128-bit security. So the best attack is in one end the baby step giant step to try to break GDH assumption, and together with the birthday paradox to try to find a session key or an intermediary key. So we have the square root of p for the baby step giant step, and 2 to the LH divided by 2 for the birthday paradox. For the explicit authenticated responder, we have the theorem 2 that gives a security of around 64 bits, because the best attack is simply to guess the tag T2. So the tag when you are in a cipher suite 0 and 2, the tag T2 is 64-bit length, and in this case, the security is 64 bits. This is the similar for the initiator explicit authentication. So, however, even if the initiator use an authenticated encryption, this has no impact on the security, as this is encrypted using the key SKey3 that any imposter can compute. So that do not give any security for the authentication initiator. For the identity protection of the responder, so here we have similarly at the key privacy security of 128 bits with the same attacks, and similarly for the identity protection of the initiator. So in the summary, so if we consider the cipher suits 0 and 2, we use a MAC tag of length 64 bits, and we have a key privacy security of 128 bits, an identity protection for both the initiator and the responder of 128 bits, and for the authentication, we have a 64-bit security each. So, and in the protocol, as said before, in the protocol, we make the use of the authenticated encryption, but that's useless in the point of view of the security, as the key SK3 is independent of XS, and any imposter can compute it. So we made we suggest some improvements. So the first one is in the case the MAC is 128 bits. So as SK3 is independent of XS, and as the MAC is 128-bit length, we have 128-bit security for the authentication. So it's simply the idea is to replace the authenticated encryption with one-type encryption, as there is no impacts on security. We have the same security for the key privacy, the mutual authentication, and the identity protection. And we even have we have the shorter message tree, because as when encrypting with authenticated encryption, this is a block cipher, when we use the one-type pad, this is a stream cipher, so the ciphertext is the same size as the plain text. So we have the same security for a smaller message tree. For the case of the Mac are 64 bits length, this is different. So we will use the authenticated encryption to have a better initiator authentication. So yeah, it was first to compute the key S key 3 depending of XS, but doing so the responder not compute the key, as to compute the key you need the aforementioned IDE that is sent in the message. So the solution was to compute two encryption. So a first encryption with the key SK3 that will encrypt IDE and external data with the symmetric key. Once the responder decrypts this message, he has the information to compute the key SK4 that depends of XS. And in the message, the initiator an authenticated encryption of T3 with the key is key 4 and the initiation vector 4. And using this, the initiator authentication reach a security of 128 bits, as we have 64 bits from the tag T3, and now we have 64 bits from the authenticated encryption. So before trying to forge a tag, the adversary will have to forge the valid ciphertext. And so the security multiplied, and we have a security that is around 128 bits. And about the length of the message tree, it will depend on the length of the plain text tree A, so IDE and EAD3, because if this message is smaller than 64 bits modulo 128, we have a longer message, and if this is not the case, we have a shorter message. This is due to the fact that T3 will be a 64-bit message that will be encrypted under 128 bits block. So we lose in some kind of lose 64 bits, and depending on the length of the text, we have either a shorter or longer message. And we can use the similar idea for the message too. So to increase the responder authentication, where you will send his information key stream ciphertext and use the authenticated encryption for a better authentication security. But this will lead to higher, bigger message too, but better security. So yeah, there may be some compromise to do here. Also, another way to the authentication is to add a false message that appears in the documentation. And with this message, that's the same idea as before. With the authenticated encryption, we have a 64 extra bits security, as the key pair key for Ietf114 depends of YS. The ciphertext C4 will depend on YS, and if the ciphertext is valid, it means that either the adversary broke the unforgeability of pi prime, or either it's the responder. So we have the advantage is multiplied by the advantage of the adversary in forging in a valid ciphertext. So this advantage is around 2 to the minus 64 and multiplied by the 64 security of the responder thanks to the MAC. This leads to an authentication security of 128. A last minor improvement is that in all our terms we have a factor n sigma times QRO. And this comes from the fact that the key peer key to E is computed according to an empty string. And because of this empty string, when the adversary makes a query to the random oracle, it can find a match with any of the sessions. So if you have 10 sessions, a single query can generate a collision with any of the 10 sessions. So that's why we have a factor n sigma. The idea to protect from this is simply to use th2 as the input string of the computation of peer key to E. As in this case, each th2 is related to a single session. So when the adversary will make a query to the random oracle, he will have to choose which session he will target. And this has no extra cost of computation, and now we have a better tighter security for the for all the for the key privacy, the authentication, and the identity protection, and therefore the security is independent of the number of users. Of sessions, sorry, independent of the number of sessions. So thanks everyone, and if you have questions, I will listen to you.
So we have John in the queue.
Yeah, thank you, Baptiste, for all this work. Really appreciate it. We made some, there's been recent issues created for these things, and for the TH2, the TH2 suggestion have had an issue and a discussion ongoing whether this extra factor is needed or not. I very recently, a few days ago, made a PR. Turns out that adding TH3 also simplifies the specification because each KDF has some strange behavior with the empty string, so we could actually remove text. So it might be worth doing just for that alone. Göran made this morning, I think, an issue for the other, and also started looking at how it would affect the implication. I think it would increase, in many cases, the message tree with a single byte to do this. But I think that needs some more discussion and analysis on GitHub.
Yes, John. So what I hear from you is that we are tracking the improvements, suggestions that are proposed by Baptiste, and that we have the ongoing discussion on GitHub around these, which is very important. And please, let's keep on doing that. I think we have Mark in the queue. Mark, did you want to comment on something, or?
Yeah, thank you. Thanks, Baptiste, for the presentation. I just had a question. I was wondering whether the sort of your work would be available, published somewhere.
Yes, so it's still a draft, but we are working with David Poncheval, and I think soon, depending on the conversation, how it will evaluate. But yes, there is a paper that's draft, so maybe soon be a preprint, and why not be submit? But yes, there is an ongoing paper.
Great, thank you.
You're welcome.
Great, thanks, Baptiste. Thanks again for all the work. And I think next is John. So just say when you know the new slide.
There's a slide.
Or you,
There's also, yeah, I think, how many, if you have like around 10 minutes, I guess, or something.
yeah, we've 20 left, so you're fine with time. Yeah.
So we can, so this is presentation about all the updates and ongoing issues. This is an overview. So version 13 was just resubmission, and then quite major changes in 14. We waited with submitting that to.
Oh, maybe it's off. Yeah. Slide. There you go.
So yeah, much better. So this is an overview of the submitted version. We waited with 14 for a long time to have a stable version. I guess the slides disappeared.
Yeah, it's reconnecting.
And then there was a recent update of the traces aligning with 14.15. 14.15 has the same buyer format. And then very recently, just a few days ago, 02 traces was submitted with a correction. I think the Oscar master salt was wrong in the draft version. Then we can go to the next slide. Yeah, next. So this is, I don't have time to go through all the changes, but the major rewrites and updates to the 3.5, which is authentication, and then a major rewrite of EAD section. And some technical change, the EAD value is now a bit string. Quite a lot of changes to the Adhoc key derivation and key schedule based on comments from the formal verification. The three main updates are that there's more key derivations to be able to use different keys in the KDF expand and extract. Before, the same key was used in both. The transcript hash and context input has been made a single context input, and then all the labels are now integers. Can take the next. Also changes to the identifier encoding. This has been an ongoing discussion with different solutions, all pretty same. Strong conclusion in the group that we need to have this 1 byte encoding, but unclear how. Now we have gone back to, before it was discussed to have integer kids in COSI. That has now been scrapped, and it's specified as there are byte strings, but they are encoded as integer. This is similar to the solution before, but it's a new solution, which is much simpler, hopefully. So hopefully this is the last version of that. Next. Here is a new schematic of the key schedule. And as before, major change. More key derivations. There's also a new key, the PRK exporter. There's a new session key called the PRK out to have a very well-defined session key. Formal verification typically wants to have a very formal session key that is, you can state properties with. Next slide. So quite a lot of changes in the processing, partly technical, partly more clarification. This EAD and ID cred needs to be passed a bit earlier. There's padding has been added to hide length of things. Optionally, quite a lot of clarification and security updates. I think we can go to the next. Next. So there's some new, now we're coming to more discussions. There's a few remaining discussions and issues left. In 15, there is a new section on authenticated operation. This was previously an empty trust on first use section, but we realized it can be included. You can, there's more options here, so it's been more generalized. And there's a lot of clarifications and security can take next slide. So now we're coming to ongoing discussions and some changes to the EAD based on the item issue created by Christian Amses, I think, about encrypted client hello types of use cases. But one of the things that popped up there was that it would be good to have a critical, non-critical flag for the EAD. And this has already been included in the latest version, I think. And negative values are now critical and positive values are non-critical. And this is quite similar to extensions in X509 certificates. I think that might please look at this and especially any processing requirement, what you're supposed to do might need further clarification. Next. Open issues. So this has, I guess most of this has been already discussed. The three first are based on the formal verification. So these, I think, are already discussed. Except this one remaining issue is that it was realized that HKDF has a length limit, depends on the hash algorithm used, but when you use SHA-256, the maximum output is 8,160 bytes. Can take next slide. I think the first question is this a problem? Normally not, but you could imagine that you have a quite large EAD, or you could have a large certificate chain, or you could have both. And so the first question, is this something we should fix? And second question, if we fix it, how should we fix it? This is a list of basically all the potential solutions we could think of. And of these, number 2 and number 5 are backward compatible. So you only need to change your implementation if you actually use long messages. And HKF expand bis here would be HKDF with a 16-bit value instead. It's still HKDF according to the academic paper, but not HKDF according to the RFC. Next. And the most promising solution, if you want to fix this, seems to just use HKDF according to the RFC several times. If you don't want to support very long messages, you don't have to do anything. And if you do, you can still use an implementation compliant with the RFC. And there's an issue, and I think a PR for this. Yeah. On GitHub. Then this is based on the formal verification. The changes to the how to encrypt the authentication in message tree. I think we can take next. And then traces next. So this has been updated, aligning with Adhoc 14. And then there's a bug was fixed in 02. There's been very recently a new bug just submitted. So I think there will come a new version of traces fixing that. Next. Then next steps, I guess that we will discuss. Yeah. Are there any questions? So we have.
So nobody in the queue. Okay, so we'll discuss this shortly. Yeah. Great, thank you. Marco?
Hi everyone, this is Marco. I have just one slide, a hackathon report. Next, please. Thank you. Yeah, it was me and Militia. We had our implementations up to date to version 15 of Adhoc. Same implementations we considered at the previous hackathon in Vienna. And in fact, we considered exactly the same setup with Militia initiator and me as responder. And well, the most effective configuration, if you want, because that's the one really bringing you to the smallest possible message queue, which is 45 bytes. And we specifically considered the cipherset 2, method 3, both peers with CCS, and KIDs as credential identifiers with KID such that it encoded as an integer on the wire. And yes, everything eventually succeeded. We converged to the same master secret and solved. And I'm aware of more people updating their implementation, so I would expect more tests in the following weeks or months. That's it.
Great, thank you. Thanks.
So we have Joran in the queue. Joran?
Yeah, I just wanted to add to what Marco said. We have confirmation from Stefan Ristotov that his implementation is also updated to version 15. And Marek, who couldn't be here, has updated the test vector code also to version 15. And there are now test vectors for ECDSA and EDDSA in a folder in the GitHub called something like test vector 15. Yeah, that's it.
Great, thanks.
Just as a clarification, when you refer to test vectors, you're referring to the JSON version in the GitHub file, right?
Exactly. Yeah,
the JSON version of the traces draft.
It's not only the traces draft. It's
the additional ones. Yeah.
There are multiple. Yeah, there are additional test vectors. Not only the two test vectors in the traces draft.
Thank you.
So there's a catalog.
Yeah.
Great. So I think that we have about 7 minutes left. I think the topic that Militia and I would like to cover is how do we get done? What's the next things? Obviously, there's some outstanding PRs and things that need to be discussed. But what else is needed now that we kind of have some of the analysis done before we're ready for working group last call? So I'd appreciate your thoughts on that. What else do we need to do before we're finished? And if nobody has thoughts, I presume the answer is nothing, and then we think we're finished.
So let's hear from John.
Yeah, I think I would say nothing more unless something pops up. But we need to. We have some current issues. There's not been coming in very much more issues. So I think we fix these issues, publish a new version. Then of course we need some implementation. But after that, I think we are ready for working group last call. We already had very substantial reviews before. Yeah.
John? John is at the queue. Okay.
So maybe as a reply to John, I mean, it seemed that, yes, so the suggestions proposed by Baptiste will also affect the key schedule and therefore also affect the traces. So they still seem to be kind of not, I won't say substantial, but important, as they affect the security level of the static mode, right? So do we need an interim to discuss those, or should we call it a break now for the summer? Or what are the people's thoughts on this?
So I guess people are agreeing with John that there's not much more to do. You're on.
Yeah, I am about to say the same thing. But so I think that we definitely need to look carefully at the security analysis, the latest input. Maybe we could have a meeting with some of the teams. I'll reach out to Baptiste here after the meeting, see if we can have a short meeting and discuss the latest input. And then we need to do the PRs, and then the specification should be fine. And of course, we need to update implementations also. But this is not as big a change as 13 to 14, I'd say. So I don't know if we need any interim meeting before the vacation. There's a lot of people going on vacation now.
Sure. Okay. So I think what I'm hearing is depending if we might or might not want to organize an interim around October time, but other than that, we'd like to hopefully get to start the working group last call before the November IETF meeting, so that the working group last call ends just as that meeting happens or something, perhaps. Does that sound reasonable?
Yes, and earlier if we're ready, but otherwise, really good plan.
Okay, so nobody seems to be screaming and objecting, which is very nice. So I think that's the plan. We'll try and aim to, with or without an interim, get to working group last call completed before November. That seems feasible to me, I think, given where we are. So it's good. And thanks all for the work. I think we're at the kind of any other business part of the agenda where we have a couple of minutes. If there is any other business. Yes, Paul, our AD, is jumping up.
Sorry, Paul, AD. Just on the previous topic, you could maybe do an early sector review if you're anyway in a sort of lull where there aren't any big changes happening. Could perhaps be useful.
Yeah, okay, that's a good idea. So once we get the next draft that resolves the issues that came out of the analysis, I think we can hit the sector review request button. Good idea. And with that, I think, Militia, anything else?
So I just wanted to pass my thanks to the formal analysis teams doing the analysis. Many thanks, guys. I mean, this is really valuable for us.
You're on?
Yeah, actually, I have a final request. Now we are, I mean, if we follow the proposal from Baptiste and David, we are making changes. And it would be great if those teams who have been analyzing the protocol could make another round and see that we don't mess up things when we make those final changes.
Sure, yeah, we should definitely ask. I mean, can't expect too much effort, but it's definitely worth asking. Okay, so with that, I think we're done for today. Thanks for coming. Thanks for all your work. Thanks again to the people doing the formal analysis. That was really good. And we may well meet next time, I guess, depending on if working group last call has any comments. Thank you.
Thank you.
Thanks, Misha.